It is time to get into lesson 6.2, and 6.2 is where we start doing some fun algebra. I find it fun. It's my favorite kind of algebra, being able to figure out what my missing variable is actually equal to by doing my math functions. So our thing that we need to learn is the opposite function, then the opposite side. And if you can learn this, math is going to be so much easier from this point forward for you, including chemistry, because you have to be able to do the opposite function then on the opposite side, even in chemistry when you get older. So as we get into this process, then we want to know what our objective is for the lesson. We want to be able to not only just be able to find the answer for the variables, but we want to be able to write out the equation that is given to us to set it up and then do the math. This is called the subtraction property of equality, big fancy terms, and I will show you what that means. So as we're going through these math problems then, I'm going to have word problems, I'm going to have setups, and if that's the case, then I need to be able to cube my math question. Some of you still have not figured out how to cube your math question yet because you're not trying to learn how to do it. Once again, C in cubes is to circle any of our numbers and units. I want to underline the question that I am answering. Sometimes there's going to be two questions that I'm answering, so I double underline it. Then I'm going to box any of my clue words that are telling me what type of math that I'm doing. And then I evaluate, I decide what I need to do, I get rid of all the junk or ignore the junk, and then I solve it. I find the answer. This particular question says, in a recent Summer Olympics, the United States won 23 more medals in the swimming than Australia. The United States won a total of 33 swimming medals. Write an addition equation that can be used to determine the number of medals won by Australia. So I know I have 23 more medals than Australia does, and they have 33 medals. And I'm underlining my question, write an addition equation that can be used to determine the number of medals won by Australia. My clue words is the idea of more. And when I look at that math packet that you all have been given, you should be marking, finding the math terms and what they indicate that I need to do as far as my math functions go. More tells me that I am adding. So then I know that total is going to be my equal sign. So if I know what I have, then I can start working through the process. So medals for Australia plus 23 equals 33 medals. So I don't have the answer, so I'm just going to put an M for my variable. I know I have something missing, then I'm going to add to 23, and then that's going to be equal to 33. So my math equation is M for metals plus the 23 equals 33. And we need to be able to know how to solve those type of questions, right? And that's what we're going to be getting into here momentarily. Right now, we're just looking at how do we set these up. And once again, setting them up is beneficial if we cube it so we know what's important and what we're being asked to do. Together, Ruben and Tarek downloaded 245.5 megabytes of music. Ruben downloaded 132 megabytes of that total. Write an addition equation that can be used to find how many megabytes of music Tarek downloaded. So I know that I have 245.5 megabytes that they downloaded together. Ruben downloaded 132 megabytes on his own. So I have to write an addition equation. Once again, equations, math problems with answers. We're doing algebra, so I need a variable. So I have to figure out what my variable is equal to. Together means what? Well, mathematically, together means addition. So I know that we're going to have whatever they are added together that's going to equal the total of 245.5 megabytes. So when I'm looking at what I have and what I'm adding, if my total has to be the 245.5, then I know that Ruben downloaded 132. So if I'm setting up for M for the music or the megabytes or the whatever it is that we are using, I find my variable. So I'm going to have my 132 that Ruben downloaded. I'm going to add my variable, whatever label I'm going to use for the piece that's missing in my math problem, and then I put my answer on the other side of the equal sign. Once again, we're going to be doing the math here just momentarily, but right now we have to be able to take our word problems and figure out how to set up the math problem before we can then look at doing the opposite function on the opposite side. So that means you need to try working on setting up a math problem, cube this particular example, and then come back and check your work with me. So hopefully you read it. Together, Zacharias and Paz have $756.80. If Zacharias has $489.50, how much does Paz have? Write an addition equation that can be used to find the amount of money that belongs to Paz. So here is a number and label. We circle it. Here's another number and label. We circle it. I'm being asked to write an addition equation that can be used to find the amount of money that belongs to Paz. My clue words, once again, are that they are together, so we know we're going to add them. So I have the two individuals adding together. They are given the total then of $756.80. So I have what Zacharias has, which is the 489.50, and I'm going to do what? Well, I'm going to add, according to my cubing, whatever Paz has. So we're just going to put D for dollars. Well, if you got that answer, then fantastic. But some of you still want to know, what's the answer? How do I go about solving those? And what we did in the last lesson was we guessed. Well, let's look at how we would actually solve this problem. So if I have that problem and I want to solve it, this is where we're going to do the opposite function, then on the opposite side. So what do we mean by functions? Well, in math, we have four basic functions. We have adding, subtracting, multiplying, and dividing. All right, well, what about the term opposite? If it's an opposite function, well, opposite means which ones usually go together. So when we talk about math families, then we know that fact families tell me that if I have addition, I'm also going to have subtraction. If I have division, I'm also going to have multiplication. So my opposite is which one I'm not using in that fact family. So if I have addition, it's going to be subtraction. If I have subtraction, then its opposite function is going to be addition. If I have multiplication, its opposite is division, but if I have division, its opposite is multiplication. So I'm going to be doing my opposite function. What do I mean by doing the opposite function then? Well, I have to start with step one, which is always, 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 I need to get my variable alone. What's my variable, Mr. Barker? Your variable is your letter. So your letter has to be left alone no matter what. That's your ultimate goal. You're going to have your letter and the equal sign that you should keep together, and everything else is going to shift to the opposite side of the equal sign. So what am I doing on the side where the variable is? Well, I'm adding $489.50. All right, so if I'm adding, what is the opposite function of that? Well, that, my friends, is going to be subtracting. So instead of adding $489.50, now we're going to subtract it. Well, how do I do that? Well, that's the easy part. I'm just going to drop it underneath the number itself and show that I'm doing the opposite function, and that's going to be canceling them out. Because if I have a positive $489.50 and I take $489.50 from it, that's just going to leave me with zero. So that gives me my variable alone on the left-hand side of that equal sign. So that's my first step. My second step is whatever I did, in this case, I subtracted $489.50. Now I'm going to do it on the opposite side. The opposite side of what? The opposite side of the equal sign. So I'm going to carry it over. Whatever math I do on one side, I'm going to do it on the opposite side of the equal sign. That's where I have the $756.80. Now I'm going to subtract, because that's what I did on the left-hand side. On the right-hand side, I'm going to subtract $489.50. All right? So we have to make sure that when we're subtracting, these are decimals. I have to line up my decimals. I have to bring my decimal down, and then I can subtract going from right to left. 0 plus 0 is 0. 8 minus 5 is 3. 6 minus 9 is not able to be done. So we borrow from the 5. It becomes a 4. The 6 becomes 16. 16 minus 9 is 7. 4 minus 8 also can't be done. So we borrow from the 7. The 7 becomes a 6. The 4 becomes a 14. 14 minus 8, well, that is 6. 6 minus 4, that is 2. 267.30. What's our label? We're dealing with money. So what we have found is that our D is going to be equal to $267.30. Now, I'm giving you a copy as a handout of these steps so you can look at it as many times as you need to. So add these to your folders so you have them and you can look at them multiple times. All right, so we're going to follow those steps over and over and over again. We're going to do the opposite function, then we're going to do it on the opposite side. So when I'm looking for my variable, because that's my first step, I have to get my variable alone. What is my variable? My variable is the x. It has to be alone. What am I doing to the x? I am adding 4. So what is the opposite of adding 4? That would be subtracting 4, right? So the opposite of addition is subtraction. This is what we call the inverse function mathematically. So if you see a math question that says the inverse function, that just means the opposite. The opposite of addition of 4 is subtracting 4, which just allows you to cancel those out. Now you have your variable alone. So we know x is equal to something. What is it equal to? Now I go to step 2, and I'm going to go to the opposite side. So now that my variable is alone, I'm going to subtract 4 on the right-hand side of the equal sign, and 7 minus 4 gives me 3. So we can see that x is equal to 3. And one of the things that you can do in order to check to make sure you're correct is you can plug that in. For x, put the 3. Is 3 plus 4 7? Yes, it is. So then as we're doing these, we're actually doing two different operations, if you will, when it comes to mathematics. So as I just mentioned a moment ago, this is called the inverse operation. Inverse comes originally from the Latin term that means the opposite, right? So in Latin, inversus means the opposite. So we're going to do the opposite operation. We're going to do the opposite function, if you will. When it comes to the subtraction property of equality, it just simply means that when I do the opposite function on the opposite side, then I'm going to find the equal amount for my missing variable. Right? So I'm doing the inverse of addition, which is subtraction, the inverse of subtraction, which is addition, the inverse of multiplication is division, the inverse of division is multiplication. So if you see the terms inverse, like on the NWEA here rather soon, then don't get confused. It just means the opposite. If we can do the opposite function, then we are good to go. Right? So as long as the same math is done on both sides, that's what gives us our property of equality. I'm doing the same thing. I'm doing the equal same math on each side that will allow us to cancel the stuff out. So when I'm given the math problems, then this is where I don't have to create my math problems. I just have to be able to do them. And my first step always is to locate my variable. So when I see my variable, then oh, wait a minute. This one's confusing because I don't have any math on the left-hand side. My math is on the right-hand side. How can I even possibly do that? It's not set up correctly. Well, it really is. It does not matter which side the math is on when it comes to the equal sign. Wherever my variable is, that's where I start the math. The opposite side is truly on the other side of the equal sign. So if it's right to left or left to right, it doesn't matter. We just do the math. So I go back to the first step and I find my variable. Does it matter that it's on the right-hand side of the equal sign? It does not. I just need to get my variable alone. So what am I doing to my variable? I'm adding 3. What is the opposite of adding 3? Well, the inverse function or the opposite function of addition is subtraction. So I need to subtract 3. And when I do that, if I have 3 fingers held up and I take 3 fingers away, I don't have any fingers. So that just cancels that out. That allows my variable to be left alone. And that's what I need. So now I'm going to go to the opposite side and I'm going to subtract. Why am I going to subtract? Because in order to get rid of the addition of 3, I subtracted the 3. Now I do the exact same math on the opposite side. 8 minus 3 is 5. We're saying that 5 is equal to x. How do I know if that's correct or not? I go back to my original problem and I substitute in 5 for x. That would give me 5 plus 3. Does that equal 8? Yes, it does. I know I am right. Once again, it does not matter which side of the equal sign the variable and the answer are on. You can have 5 minus x, since that's the way the math problem is set up, or you can have x is equal to 5. Either one is the correct answer. All right, you guessed it. It's now your turn to work on it. So tell yourself, get your variable alone, do the opposite function on the opposite side, look at your handout if you need to, solve for x, come back and check. So hopefully you have an answer for x. The first thing you did was you said, well, I have to get my variable alone. My variable in this particular math problem is the x. Then I'm looking at the x and asking, well, what am I doing to the x? I'm adding 33. Now, how am I going to get rid of the adding of 33? I have to do the opposite function, right? I have to do the inverse operation. The opposite of addition is subtraction. So you're going to subtract 33. Once again, that just cancels this out. So now what happens is I get a lot of students are like, I don't want to put forth that half a second and use my lead and show that work there. So I'm just going to ignore that and not do it. Well, when we start getting into 2, 3, 4 steps of algebra and you're not showing this particular step here, you're going to get yourself so confused and lost, it's going to be very difficult to get to the right answer. So when I ask you to show that you are doing the opposite function, that you are subtracting with 33, and then you're crossing them out to cancel them out, there's a reason for it. I'm encouraging you to be a better math student. Now continuing on. So now what we have on the right hand side is we have the equal sign and the x. So I know I'm going to get my variable alone and solve for it. So now what do I have to do? Now I have to do the opposite side. I'm going to do the same opposite function, which was subtracting 33. I'm going to do it on the opposite side. So I have 570. Step 2 is to subtract the 33. 0 minus 3, I cannot do. So we borrow. 7 is going to become 6, 0 is going to become 10, and 10 minus 3 is 7. 6 minus 3 is 3, 5 minus nothing is 5. So are we saying that 537 is what x is equal to? We sure are. And if I would add 537 and 33, then I'm going to see that that is equal to 570. Once again, you could put it as 537 is equal to x, or x is equal to 537. Both are the correct answer because it does not matter which side of the equal sign your work or your answer and your variable go on. All right, so now what about these? Now I've got mixed numbers. It's okay. Don't freak out about mixed numbers. We just have to think about the math that we have reviewed all year so far and just simply do the steps. Math does not change simply because we have fractions or decimals or anything else. So stop worrying about it and go back and review if you don't know what to do with addition and subtraction of mixed numbers. All right, so if I don't remember, I have to put forth that effort. Think about it. Same process then, doing the opposite function on the opposite side. When I have a math problem, I locate my variable. My variable is the x, and I know that I'm adding to the x. Therefore, the opposite function of adding is going to be subtracting. So in order to get my x alone, my variable alone, I do the opposite function of adding 3 3/4, so I'm going to subtract 3 3/4. Once again, that simply cancels out on the side where the variable is, so that I have my variable alone, because that's what I need. Now I'm going to do it on the opposite side. So when I do it on the opposite side, that tells me I'm going to have 7 1/2, and I'm going to subtract 3 3/4. Then I have to remember my questions that I ask myself when it comes to adding and subtracting fractions and mixed numbers. Can I subtract fractions? Sure I can. I can do that math, right? But what do I have to have? I have to have a common denominator, right? Do I have it? No, I don't. So what am I going to do to get it? I got to create it, right? So if I multiply by my opposite denominators, then that's going to be an easy one-step process, or you can find the greatest or least common multiple and use that. If I just multiply by opposite denominators, that's always going to work. I have a 4 at the bottom, so I'm going to multiply the top by 4s. That's going to give me the whole number of 7, but when I multiply my 2 times 4, I get 8, and when I multiply 1 by 4, it gets 4. Now I have a 2 as the denominator at the top. So I'm going to go down the bottom and multiply by 2s. And 4 times 2 is 8, and 3 times 2 is 6. And then I just keep my whole number of 3. Now do I have a common denominator? Yep, I do. What am I going to do with it? I'm going to keep it, and then I'm going to subtract my numerators. So 4 minus 6, can't do that, right? So we've taught this, we've gone over this, we borrow from the 7, 7 becomes 6, and then I'm going to carry one whole. That one whole has to have the same denominator that we have in the math problem. So we're adding 8 eighths to it. When I have my denominator of 8, I add my numerators. 8 plus 4 is 12. Once again, the shortcut is I take my denominator, I add my numerator, and that just gives me 12, right? So the denominator plus the numerator gives me my new numerator. That's the shortcut to remembering how to create a common denominator by borrowing. When I subtract then, I have 12 minus 6, which is 6, and then I go to my whole numbers. 6 minus 3 is 3. So we are saying that x is equal to 3 and 6/8. Well, I have to reduce, right? 6/8 is both even, so I'm going to have to divide by 2, and I get 3/4. And now I can say that 6 minus 3 is 3, so I end up with 3 and 3/4. What's equal to 3 and 3/4? The x's. So do I need to have x is equal to, or can I just have 3 and 3/4? Nope, you have to have the x, the m, or whatever the variable is that we're using in the math problem, so that I know that that is my label. All right, so as we're doing these, same thing. I locate my variable and I do the math. What is my variable in order to get it alone? My variable is going to be the k. It has to be gotten alone. Once again, I have fractions. I have to go through my same questions. If I'm adding 5/8 to it, I'm going to subtract 5/8 from it. That's my opposite function, and that allows me to cancel them out. Therefore, I have k is equal to something. So if I subtracted by 5/8, I then do it on the opposite side, and I'm going to subtract by 5/8. And if I'm subtracting by 5/8, then I have to go through those questions again with fractions. Can I subtract fractions? Yes. What do I have to have? Common denominator. Do I have it? No. So I have to create it. Common denominator of 8. So I'm going to multiply by 8s from the bottom to the top. And I end up with 1 times 8, which is 8, and 4 times 8, which is 32. Keep my whole number of 2. At the top, I have a 4, so I'm going to multiply by 4s, and I have 8 times 4, which is 32 again, and 5 times 4, which is 20. Can I subtract? Now, but do I have the same denominator? Yes. So what do I do with it? I'm going to keep it. But if I can't subtract 20 from 8, then I have to borrow. And when I borrow from the 2, it becomes a 1. And what am I carrying over? I'm carrying over 1 whole, and that 1 whole has to have the same denominator that we have up there. So I'm carrying over 32 over 32. I'm adding that to the 8 over 32. Once again, the shortcut is simply, if I add denominator and numerator, I get my new numerator. Either way, it's going to be the same math. 8 plus 32 is going to give me a numerator of 40. Now I've already kept my denominator, so I can subtract 40 minus 20, which is 20. I don't want to leave it that way. I need to reduce, right? So I could reduce by 2's, but I still would have to reduce again. So when I reduce by a larger number, I know 4 will go into both of them. So I'm going to reduce by 4's. And 4 goes into 25 times, and 4 goes into 32 8 times. Can that be reduced? Nope, that's as low as it's going to go. Do I have any whole numbers that are left over? I do. I have a 1. So I know that it's going to be equal to 1 and 5/8. What is going to be equal to 1 and 5/8? K is equal to 1 and 5/8. Once again, keeping the label with my number. So now that I have my answer, I go back through this process. We're always going to do the opposite function. Wherever the variable is, it has to be my first step. Locate the variable and know that you have to get it alone. So I'm going to do whatever math is on the left-hand side or the right-hand side, wherever the variable is, I'm going to do the opposite function, right? I'm going to do the inverse property. If it's addition, I do subtraction. If it's subtraction, I do addition. If I have multiplication, I'm going to do division. If I have division, I'm going to do multiplication. Then I do that on the opposite side. Keep this handout because we're going to use it over and over and over again for the next several lessons. All right, so you do have a homework assignment. It is due in the morning. Come and get it from me. And if you have any questions, please ask.